Hello everyone. So today I will explain you how to fix table retrieval in a RAG system. This question was asked in an interview that if a PDF contains a table, the answer is on the row 14 column 3. After chunking, the table structure is lost and the retrieval fails. How would you solve it? So imagine you are in a AI engineer interview and interview asks you this question. This is one of the those production level rare question that separates beginner from experienced AI engineers. In this video I will explain why this problem happens, why normal chunking fails, the production architecture used by companies, and how you should answer this in an interview. Let's get started. Suppose we have a PDF where employee department salary like that is there. Now imagine interview asks what is on the row 14. So you will simply give the answer. But here what happens in normal rag pipeline, the PDF is converted into the plain text and then chunked every 500 to 1000 characters and something like that. It will be in a paragraph. Now the row column relationship is gone. The embedding model no longer knows that the particular column belongs to that particular department, and retrieval fails and the LLM hallucinates. So why this happens? So generally what happens if some beginner is going to do this, so what they will do, they will try to chunk a PDF. So simply they will chunk this PDF, and after that they will do some embedding on this. Everyone will do like that if someone is beginner, right? So I think everyone's thought process will be similar. And after embedding you have to put it onto a vector DB. It can be your quadrant, pine cone, anything. So this is the normal flow. And then for the retrieval also they will do the vice versa, means they will do the embedding again, searching on the vector DB and retrieves. So this works for paragraph, but tables are different. Table contain a special relationship, column, rows, headers, merge cells. If you flatten everything into the text, you destroy the structure. The embedding model cannot reconstruct it. So the solution one is, we will propose one solution. This is our solution one. So solution one is, never extract raw text, instead use layout aware document parser. So some of the tools are like you have to use document parser. So document parser are like Azure document, Intelligence, LlamaParse is there, another thing, AWS Extract is there, Textract, and Unstructured .io is also there. For the these are the these tools understand the document layout. Instead of returning in a single line, they will return with the help of something some delimiter. So they preserve row number, column number, table boundaries, page number. Now the table still exists. And the solution 2 is, and other process will remain same. So solution 2 is like, we will do atomic chunking. So what it is, I will explain you. So the next mistake is splitting tables. Imagine chunk 1 contains employee, department or something, and chunk 2 contains the value of a table. Now no embedding model can understand this. Instead, keep the entire table together or split logically. For example, header plus row 1 to 20, header plus row 21 to 40 never is split inside a row. Think of a table as one atomic unit. Okay, this is a different, means you have one table like this, you have different columns. Okay, means you have table, don't split it as vertically, means it should not be like that, it should be like that. This one means from table 1 to 20, and from 20 to 40 will be a different table, like that you have to do. Now now solution 3 is preserve metadata. So what metadata is, means metadata is the header, columns, rows kind of information. So every table chunk should carry metadata. So it can be like on this page number 12 the table id is for row from 1 to 20, headers will be like document name, section name, all these things. Now suppose the user asks what is the salary in row 14. So your retrieval engine can immediately filter page 12, table 4, row 14. Instead of searching million of vectors, this makes retrieval both faster and more accurate. Now for the solution for hybrid search. The production systems rarely rely on the vector search. Instead, they combine semantic search and keyword search. Metadata filtering, this is called hybrid retrieval. For example, if query is employee id 12345, keyword search finds the exact id. Semantic search understands similar wording. Metadata narrows down the search space. Together, retrieval accuracy increases dramatically. Now the solution 5 is reconstruct before sending it to LM. So even after retrieval, don't send fragmented rows. Instead, reconstruct the original table. Now LM sees the complete context. Reasoning becomes more reliable. Now I will design a production ready architecture. How should it be? So first we will put where we will be having our PDF, and then after that there will be layout parser. Layout parser will detect the tables. After that we will do atomic chunking. Chunking means you have to segregate the table rows. Then there will be a metadata generation, means metadata is required, right? Metadata chunking, metadata generation, that this page contains this row number data, and then we have our embedding model. it here. Means it will PDF will be first layout parser, after that it will detect the tables, after that it will do atomic chunking, and then after that there will be metadata generation, and then we will send it to our we will send it to embedding model, and from embedding model it will go to the vector db, and from vector db there will be hybrid retrieval, and after that table reconstruction. And then we will pass it on to our LLM, and then we will get our final answer. So this will be our architecture. So I will summarize this one. The root cause is the naive text chunking destroy the row column relationship in tables. Instead of extracting plain text, I would use a layout aware parser such as Azure Document Intelligence or LlamaParse to preserve table structure. I would keep tables as atomic chunks or split them by logical row groups while retaining headers. Each chunk would include metadata like page number, table ID, row indices, and column names. For retrieval, I would use hybrid search combining vector similarity, keyword search, and metadata filtering. Finally, I would reconstruct the original table before sending it to the LLM. This ensures the model reason over structured data and significantly improves retrieval accuracy. If you are preparing for AI engineer, Gen AI, or RAG interviews, questions like this are becoming increasingly common because companies want engineers who can build production ready AI systems, not just prototypes. If you found this video helpful, don't forget to like, subscribe, and share it with someone preparing for AI interviews. I will see you in the next video with another real world design question. Happy learning.